Hi, PreCalculus. Welcome to example 3 for section 4.1.2. These problems are a little bit more tricky, especially the U-try is considerably more tricky, just because there's a little bit of algebra or a lot of bit of algebra you have to do before you can actually plug it into your calculator. So looking at example number 3, we've got this hot air balloon 650 feet off the ground, and it can look down at the greenhouse with an angle of depression of 28 degrees. But we know from geometry that if I have two parallel lines, and I think this is called a transversal, but some geometry teachers probably screaming or rolling over right now, but if this angle of depression is 28 degrees, then the angle of elevation on the other side is also 28 degrees. So we know this angle of elevation is 28 degrees, and then from the blue house, since the angle of depression from the hot air balloon is 52 degrees, then the angle of elevation from the blue house is 52 degrees. So what we're looking for is the distance between the two houses. Well, the distance between the two houses is this y value here. But I can't use this big triangle just to find y, because I have this angle, I have the opposite side, but the side I'm looking for would be x plus y. Well, I don't know what x is, so I can't find x plus y. So what we're going to have to do is use two different triangles to solve this. So first, I've got this triangle here for the blue house. And for that one, here's my angle. I know opposite, and we're looking for adjacent. So I've got tan 52 is equal to 650 over x, which means x is equal to 650 over tan 52. Now before I go and I solve it, when I go and solve it here, I'm going to get a decimal approximation. If I use that decimal approximation and plug it in over here, then it's going to give me a gross approximation, so gross that it'll take away, like remember for the AP calculus, you have to have it to 3 decimal places. Well, if you start approximating early, then your final answer is going to be off by at least 1,000th of a point. And then that means you lose your point for the correct answer. So you could be really close, but because you had an approximation error by plugging it in too soon, then you lose your point for the entire problem, which would be very sad. So I'm going to leave it just like that. I'm not going to plug it into my calculator until I get y by itself. All right, let's look at the big triangle. The big triangle would be this guy here. Here's my angle again, 28 degrees, so tangent of 28 is also 650, and then on the bottom I've got x plus y. I'm going to do a little bit of algebra before I plug this guy in, so it's not too bad with that fraction. So I'm going to multiply both sides by x plus y. Here I get x tan 28 plus y tan 28 is equal to 650, because these guys can swap. I'm trying to get y by itself, so I'm going to go ahead and subtract this guy over here. So y tan 28 is equal to 650 minus x tan 28. And then to get y by itself, I'm going to divide off tan 28. And so over here, these guys cancel, and I get y is equal to, and now I'm at a point where I'm going to go ahead and plug this guy in for x here. So I get 650 minus x, which is 650 over tan 52, times tan 28, all over tangent 28. All right, and I know that looks big and scary, but now that I've got y by itself, that's what I'm going to plug into my calculator, which will help avoid having any sort of decimal approximation error by figuring out what this guy is early on. Nice thing about calculus is you can actually leave it like this in calculus. You don't have to put it into a calculator unless, let's pop it up on my screen, unless it's like a calculator exam and they want to see a decimal answer. If it's free response, you can leave it just like that and leave it how you would put it into a calculator. All right, so let's put that into a calculator and see what we get there. So we've got 650, in my numerator I got 650 minus 650 over 1052. I need to be very careful, so the 650 divided by tangent 52 times, what's left up there, tangent 28. And then I'm going to come out of those parentheses and divide that whole thing by tangent 28. Tangent 28. And that's what I get, is 714.637. You also want to go back and check and make sure it looks exactly like it does in your paper, which it does. I got 650 minus 650 over tangent 28, or tangent 52 times tangent 28, all over tangent 28. So this guy here is equal to 700, oh, be careful, Miss Harris, you plugged into your calculator. Now we need the approximately equal to 714.637 feet. All right, go ahead and pause your video. Take a look at this one. I'm going to tell you right now, there's a lot of algebra involved once you get it set up. All right, did you get this one done? Let's see how you did. Okay, so we've got an angle of elevation from the first car to the top of the apartment building is 48 degrees. From the yellow car, it's 64 degrees. We know this is 22. How tall the building? This is what we're looking for. And then we've got this part here, and we don't know how much that is, right? So I've got two different triangles. So let's first look at our big triangle. Our big triangle would be, let's see, we've got opposite over adjacent again. So tan 48 is equal to x, which we're looking for, over 22 plus y. And then for our smaller triangle, I've got tan 64 is equal to x over y. Now we are trying to figure out what x is, and we've got these two equations. I'm going to go ahead and solve this guy for y. So y would be x over tan 64. And again, I'm not going to plug that into a calculator. First of all, it's two different variables. But second of all, if I plug it into a calculator, give me an approximation error. So I'm going to take this y here and plug it in here. So this guy is going to go just for that y. So my equation becomes tan 48 is equal to x divided by 22 plus this guy is x over tan 64. So here's the deal, guys. This is what I'm talking about in calculus. They would be able to get to this point, but what they're struggling with is the algebra to get x by itself, what you hear. You've got a compound fraction. You're going to have to do some fraction math to find a common denominator in the bottom. You got to know when you want to flip the guy. So it's quite complicated. But it's not the trigonometry that's hard here. It's all this algebra once we set up a problem. So this is going to be x. Here I need a common denominator between these two guys. The common denominator is going to be tangent 64. So I'm going from 1 to tangent 64. I'm going to multiply by tan 64. So this would be 22 tan 64. This already had the common denominator, so it's going to stay x. All right, now on that side, I've got a fraction over a fraction. So I've got x over 1 times the reciprocal of this guy, which would be tan 64 over 22 tan 64 plus x. Multiplying that guy straight across, I get tan 48 is equal to x tan 64. 1 times this guy is just 22 tan 64 plus x. All right, I'm going to get rid of this fraction, so I'm going to multiply both sides by 22 tan 64 plus x. See where the algebra is getting very tricky here. So 22 tan 64 times tangent 48 would be 22 tan 64 times tangent 48 plus x times tangent 48. So I went ahead and distributed it when I was multiplying. So I did tangent 48 times the first part, this piece, and then tangent 48 times this piece, and that's how I got this. And that's now equal, this guy would cancel with this one on the other side, so I just get x tan 64. All right, what are we solving for here? X, right? We want the height of this building. So anything with an x is going to come over to one side. The piece that doesn't have x is going to stay on this side. So 22 tan 64 tan 48 is equal to x tan 64 minus x tan 48. Last year I said, don't worry, just go ahead and plug in into the calculator, you'll have a small decimal error, but it's not helping them. I need you guys to build up these algebra skills so it's not such a big deal next year. What can we factor out of this side? X, right? So this is 22 tangent 64 tangent 48 is equal to x times tangent 64 minus tangent 48. Get x by itself, I'm going to divide that off. And I'm finally at the point where I've got x by itself over here, and this big beast over here is what I'm putting into the calculator. So under my calculator, I'm going to put 22 tangent 64 times tangent 48 divided by tangent 64 minus tangent 48. When you put in your calculator, make sure you put parentheses around your numerator, divided by this guy here. When you plug that in, I'm going to go ahead and put my approximation. So this video isn't too terribly long. When you plug that in, you should get 53.311 feet. That is the height of this building here. All right, that's it for 4.1.2. Tomorrow in class, you're going to do an activity that incorporates what we did today in class, and then these application problems.